Okay, we're going to start our section, the third section in chapter 2, so that's section 2.3. And as always, we start with our learning target, and we're going to review what it is that we're going to try and learn, our goal for the day. We're going to learn to multiply positive and negative fractions. We do have one new vocabulary term, and the new vocabulary term is called dimensional analysis. Dimensional analysis is a process of including units of measure when you solve your equations. Units of measure when you solve your equations. So let's jump right into it. To multiply fractions, multiply the numerators and multiply the denominators together. So let's do an example here. I've got the fraction 2/3 times the fraction 4/5, and I simply multiply the numerators together and I multiply the denominators together. The numerator is 2 times 4, which would be 8. The denominator is 3 times 5, which is 15. Is there any way to reduce 8/15? Not that I see. All right. As we look at this example right here shows us the answers in variable form. And if I work this out, I'm going to have A times C over B times D. So I'll have AC over BD as I multiply those two fractions together. Here's a practice problem, another one. 3/7 times 8/9. Well, I multiply the numerators together and I multiply the denominators together. So 3 times 8 is 24. 7 times 9 is 63. Is there anything that's in common to both of those? I think I can divide both sides by 3. So I can divide 24 by 3 and get 8. And I can divide 63 by 3 and I can get 21. How about anything from there? Don't believe so. My answer then is 8/21. How about this one? Well, I'll show you a little bit of a shortcut. Yes, we are going to take the numerators times each other and the denominators times each other. However, as I notice, there's a common theme between 5 and 15. I'm going to divide 5 into the numerator, into this numerator, and get 1. I'm going to divide 5 into there and get 3. All right, so I've got 2 times 1 is 2, and I've got 3 times 9 is 27. 2/27. I don't see anything that can reduce that fraction. So moving on to another example here, multiply negative fractions. All right, is there anything that can be reduced here? Well, I can do 3 into 3 here and get a -1, and I can do 3 into 3 there and get 4. So I've got -1 times 7 is -7. And I've got 4 times 4, which would be 16. So it's -7/16. How about anything that can be reduced there? Not that I can think of off the top of my head. I can choose to, on this problem, I can choose to put the negative up here with the numerator. So I can have -2 times 5 and 15 times 9. But again, I'm going to try and simplify. 5 will go in there 1 time, 5 will go in there 3 times. So I have -2 times 1 is -2. And 3 times 9 is 27. So I have a -2/27. 3 1/5 times 1 1/3. I'm sorry, 3 1/5 times 1 3/4. I need to write those as mixed numbers first. So I'm going to go 3 1/5. I'm going to write that as 15 plus 1, or 16/5. And this would be 7/4. 16/5 times 7/4. I can do a little bit of reducing here. I can put a 4 into there 1 time, and I can put a 4 into there 4 times. So I've got 4 times 7 is 28, and I've got 5 times 1 is 5. 28/5 I can reduce. That would be 5. We go in there, and 3/5 remainder. 5 3/5 remainder. Same kind of problem here. I can take 3 times the, 5 times 3 would get 15 plus this 2. So that would be 17/5. Here this would become 18 plus 2, or 20/9. So I've got 17, sorry, let me rewrite that. I've got 17 fifths times 20 ninths. I can reduce this. 5 will go in there one time, 5 will go in there 4 times. Any other reductions? Not that I see. So I've got 4 times 17, 28, and carry the 1 for 58 over 9. I don't see anything that will reduce 58 ninths, so I'm just going to take 9 and divide it into 58. 9 would go in there 6 times. 6 times 9 is 54, and 4 remainder, so it'd be 6 and 4 ninths. 6 and 4 ninths would be the answer. A word problem that does the same, that we're going to be doing the same way. Last summer, the 7th graders performed a total of 250 hours of community service. If the 8th graders spent 1 1/5 of this much time volunteering, how many hours of community service did the 8th graders spend? I'm going to use E for the 8th graders' time, and I'm going to say that's equal to the 7th graders' time, which was 250 hours, times 1 1/5. All right, so 250 over 1 times 1 1/5. 1 1/5, I'm going to write as 6 fifths times 250 over 1. Well, 250 and 5 are factors of each other. 250 divided by 5 is 50, and 6 fifths, so it's 50 over 1 times 6 over 1. 50 over 1 times 6 over 1, I multiply the numerators together, and I would get 300 over 1, or simply 300 hours. A low flow shower head used 2 1/2 gallons of water per minute. If family members shower for a total of 2 1/3 hours per week, how much water does the family use? Well, 2 1/3 gallons of water per minute, and this is per hour. So I need to do some conversion here. I'm going to say 2 1/2 gallons per minute, but I want to find out how many there are gallons per hour. So I'm going to take that times 60 minutes over 1 hour. That's an equivalent fraction. That's actually equal to 1. But by doing so, my minutes cancel out, and I'm going to get 2 1/2 times 60, which would be 150 gallons per hour is how much is used. 150 gallons per hour. Now, if I shower for 2 1/3 hours, 2 1/3 hours, so I'm going to take that times 2 1/3, I've got 150 over 1 times this becomes 7/3. All right, 150 and 3, the numerator here and the denominator here, this would become 50, this would become 1. So I've got 50 over 1 times 7 over 1. 50 times 7 is 350 gallons.